Okay, so this is going to be a video about the E24 series. So what I'm going to go through is what the E24 series is, um, what you can do with it, um, that's pretty much it. There's only two parts to this lesson. Okay, so what is the E24 series? The E24 series, as you can see, is a set of numbers from 1 through 10. Okay, you can't see the number 10, but basically this set of numbers splits the number 1 and 10 by 24 parts, if you count there's 24 numbers here. So it cuts it up in 24 parts, right? And every number here is a number there. So the first cut is at 1, then the second cut is at 1.1, and then so on and so forth. And 10 is not included. So the last cut, the 24th cut, will be 9.1. I'm not going to go into how they determine where to cut in between 1 and 10, because there's no point learning it. Actually, yeah, no, I'm not going to teach. No, it's fine. Okay, so that's pretty much what the E24 series is. It's just numbers, a set of numbers from 1 through 10, and there are 24 numbers. You may have also heard of an E12 series or E6 series or E3 series. Now, just from the information I've told you, I'm very sure you can infer about how those numbers look like, how those sets of numbers look like. For example, the E3 series would have three numbers, so it cuts 1 through 10 into three parts, and then the E12 series has 12 numbers, and yeah, that's pretty much it. And I think there's like an E96 series. It goes up pretty high, but okay, right, that's not really important. So that's this set of numbers. What can you use this for? You can, I'll just say what you can use this for, and I'll explain after that. In our syllabus, we learn that we can use the E24 series for resistors and capacitors. Yeah. What that means, I'll go into just in a while. Okay, which is now. All right. Let's say we have a circuit. Okay, let's say we have a circuit. 5 volts, and then we have a resistor here, and a resistor here, and then ground. Okay, let's say we're designing a circuit, and this is a basic voltage divider. If you don't know what a voltage divider is, you should watch the video on voltage dividers, and I think there's a video on voltage dividers. Okay, anyway, so we have this circuit now, and we're designing it. Let's say we're designing it, and then let's say we let R1 be equals to 1 kilo ohm. Let's say we let it be 1 kilo ohm. And then let's say, right, we want the output at R2, like let's say we have a voltmeter here, right, to measure the voltage. Let's say we want the output at R2 to be 4.2069 volts. Let's say we want this absurdly specific voltage lah, okay? So the last piece of the puzzle is we need to find out the value of R2. So what is R2? And again, uh, this is very easy if you already know about voltage dividers and the equation on voltage dividers, and if you don't, please go and watch the video. Basically, the two resistors here, the voltage as the power, and the output voltage, right, can be all described in one equation, and this is the equation. Okay, I'll just briefly explain what this is lah. 5 volts. Oh wait, okay, wait, I'll just cut to the chase. I won't explain it much. Yeah, and then, oh wait, multiplied by 5 volts equals to 4.2069 volts. Okay, so I'll just explain briefly what this is. This is basically saying that the output voltage, or the voltage across R2 is this when the power supply voltage is 5 volts and R1 is 1 kilo ohm. Okay, so that's pretty much it, and we can actually do some math to find out the value of R2. So I'm going to go ahead and do that now. I guess as practice you can pause the video to try it out yourself. Okay, I'm going to go ahead now. Oh, this is going to be a pain. Why did I choose this number? Okay. Oh. Okay, and then we get this. Alright, I'm not writing all of that out. We get R2 is equals to this kilo ohms. Okay, yeah. So in order in this circuit that we have just designed for the output at across the voltage across R2 to be 4.2069 volts, R2 needs to be this very specific number. Okay, and then let's say okay, we're done designing and want to we actually want to turn this into reality. Okay, give me a second here. Okay, and then now let's say we actually want to put this circuit into action. So we can start building out actually, like on our breadboard or whatever. We can put in a 5 volt power supply. We can put in the 1 kilo ohm resistor, but we will actually encounter a problem where we will need a this very specific resistance of a resistor. So how do we go about finding this resistance? We just okay, so basically, right, manufacturers of electronic components or manufacturers of resistors and capacitors, right, only um, manufacture resistors or capacitors following this set of numbers. So pretty much they only sell like 8.2 kilo ohm resistors or 2.7 mega ohm resistors. Okay, I'll go a bit more in depth on how to find the resistor you are looking for. Okay, wait, let me describe the problem even more. So basically, you are not going to find a manufacturer that is going to sell a 5.304375236 kilo ohm resistor. And you're going to, and since these manufacturers only manufacture the components based off this sheet, right, you're going to have to find a number in here that matches closest to this number here. So okay, let's just go and look for a number that's closest to 5.304 whatever. Okay, 5.30, and okay, pretty much the only ones that are closest is 5.1 and 5.6, and then the rest are either too large of a value or too small of a value. So our choices right now is 5.1 and 5.6. So okay, 5.1, so it's between this and this 5.6, right? Yes. Okay, so now, right, as the designer, how do you decide between this and this? Okay, if your circuit in question, right, requires this very specific number, then you are screwed, and you're just gonna have to pick this. Or you can go to the E96 series or the E100 something series. Okay, but that's not in this. That's not what we're gonna talk about. This is just a very extreme case. So what do we pick? Do we pick 5.1 or 5.6? Okay, in an actual practical and like a practical situation that makes sense, um, you could get a lower, okay, so this is a lower resistance value than this, right? It's lower. You would get this, right? And then you would put a potentiometer. So you would have this resistor here. And then you would have a potentiometer. Let's just say this is a potentiometer. Okay, wait. Yeah, okay. Let's say you want this to be this resistance lah. Oh, you want this, the total here to be this resistance. You will put this in here, and then you would create a potentiometer, and then you will fine tune until you get this specific number. Not these numbers lah, like numbers that actually made sense. So this is how you would do it normally. But let's say you're not gonna do that. Let's say you don't care about precision. Then normally, right, I would actually suggest for you to take the higher resistance value. Just take the higher resistance value if you are debating between two values, uh, and you don't know if you want to pick the one that's closest, then you pick the higher resistance value. Or you can actually calculate which is closer to this. Like what's the difference? So okay, I'll actually do that right now. Okay, yes. So the difference for this is 0.2043 something something. Okay, wait. Okay, and the difference for the 5.6 is 0.295 something something something. So just from this, right, you can actually see that this value is closer to this value as compared to this. So in the case where you really need the precision, right, then you should pick the one that's closest to your actual value, which would be this in this case. How I calculated the which one is closer, right? In this case, I just took your original value minus the smaller one, and then this one, right, I'll just take the larger value minus the original value. Then that already gives me the difference between the numbers. Okay, so you already have three options, right, on which resistance value to pick. And that's pretty much it lah. Oh, and okay, yeah. So these are like normal numbers, right? But what if you need what if you need, let's say, a 696 ohm resistor? What if you need this? Then you will have to like convert this lah. So what I mean by that, right, is using prefixes. So you convert it into to a suitable prefix first, like milli, I think. Okay, no one uses milli ohms but it is yeah, okay, so it will be, oh, it will be 0.696. Okay, so they don't have 0.696, so we're gonna have to maybe into decim ohms. So like 6.96. Then you go and look, okay, is there a 6.96 here? Ah, this number, very, very close to 6.96. Then you see, okay, maybe 6.96 is like in between this. So like because you have in the set of numbers, right, you have 6.8, you have 7.5, right? And this number is in between here. Then those three things I said earlier, right? The one where, oh, you can pick the smaller value, add a potentiometer to get this 696 specifically, or you can, wait, this is not deci, this is like is there even a prefix for this? It's not deci, sorry, it's like this, is this lah. Okay, just imagine it makes sense. Okay, yeah, so you have three options, right, when you're putting it on the board. you can pick the smaller value, and then you can add a potentiometer to reach 696 ohms, or you can pick the higher resistance value if you don't care which value is closest, right? This is actually good enough already. Or you can pick what is closest by calculating. So I mean, in this case, you don't really have to calculate. Obviously, this value is closest. And if it was me, right, in a practical case, I would then pick this. Yeah, I'll pick this, and I will consider the which value is closer thing. Okay, so that's if you had like a 696 ohm resistor. But what if you had a 420696? What if you need this value of a resistance? Then again, you have to convert it into, okay, not really standard form. Oh, actually yes, you have to convert it in standard form. So you have to get it into like this, and then this would be what, 1 2 3 4 5. 1 2 3 4 5 6. Yeah, okay. So this would be mega, I think. So you need a 5 point, yeah, let's say you need a 5.420696 mega ohm resistor. Then you look here, okay, what is close to my 5.420696? Like this and this. So because yeah, it's in between here and here, then you follow the method on how to select which one you want, which resistor you want. So okay, why is this important? Okay, I already addressed this. It's important because this is the only way that you're going to get your resistor, or this is the only way you're going to get your capacitor. Oh, it applies, everything I just said, right, is the same for capacitor. So I'm not going to like do an example with capacitors. So why is it important? It's because they only have resistors with these values. I mean, they have other values, but in the electronics lab, in our electronics lab, everything follows the E24 series. So when you are doing your calculation for your coursework, and let's say you need like a 1250 ohm resistor, then you either just go to the back, right, and then just look what is closest, or actually, right, you can do a calculation, and then you put in your report, and you quote the E24 series, and then you say, I found these two values that are closest to 1250 ohms. Oh, you have to say first, I put it into a suitable prefix, yeah, yeah, like kilo or whatever. So you would now have 1.25 kilo ohms. Then you find then you say, you write, you find two values that are closest to this number, which is 1.2 and 1.3. Then you say, oh, actually in my use case, right, precision, I suppose, is not that big of a factor, and I guess, and so I actually picked 1.3, which translates to 1300 ohms or 1.3 kilo ohms, as it would technically add some protection for against high speed current as compared to 1.2. That's why I pick 1.3, or whatever your reason is for not for picking a higher resistance value, right? And then you pick this, then you say that, right, and that is ultimately more credible. It makes you seem like you know what you're doing. You definitely don't know what you're doing, but it makes you seem like you know what you're doing. And then when the person reads it, oh, okay, yeah, this guy knows what he's doing. So if you become an engineer, you're going to use the E24 series for something else. But right now, as a student, you're using this to bullshit. Honestly, you don't need this to pick your actual resistance value or capacitor value. I have to admit, I as well, right, when I calculate I need a 9050 kilo ohm resistor, I just go to the back and then I see what's closest and I just pick it up. But if you want to elevate your report, you should include that when you calculated something, you have this specific value, and you use the E24 series to pick your resistor or your capacitor. That's mainly the main use. Okay, I don't know if you need this for the exam though. Oh yes, yes, there'll be a question, right? Oh yeah, I forgot about that. There'll be like a question where they maybe they have this, right? Like maybe this is a question. And then they say, oh, and the output at R2, the voltage across R2 is this number. So can you find the resistance? What's the value of R2? Then you find, right. Then the next part of the question is, okay, now can you pick a suitable resistor from the E24 series? I'm sure you have encountered a question like this. So okay, and then there's a second use lah. First use bullshitting in your report, and the second use is in the exam. There will most likely be a question like this. Then using the method that I just taught you maybe a few minutes ago, you go to E24 series and then you search out uh then you search out the value, and then if they ask for a reason, you just say lah or whatever. Okay, yeah. Wait, how do I pause this? um I don't want to stop recording, I want to pause recording. I'm sure there's a pause button somewhere. I've done it before. um okay, I guess I'll just wait. Alright, so this is a practice question that I created. And this is the question. You can pause here to try it out yourself, then like unpause to check if you're right. Okay, so let's go ahead and read the question or analyze the question. So we first see this circuit here, and I mean, there's nothing much to talk about this circuit. It's pretty basic, so let's move on. Oh, I mean, we can denote that there's a voltage divider here and an LED power, whatever. Alright, that's pretty much it. So let's just read the question. Part A asks us to find a suitable value for R1 such that V1 would be 4 volts. Okay, so let's just do part A first. So this is more voltage divider stuff. If you don't know, again, if you don't know anything about the voltage dividers, just watch the video, which I think exists. Yep. Alright, so okay, when you start, right, when you start the equation, generally it's better to put the units first. So that means I'll be doing this 6.9 volts equals to, and we want 4 volts, so we do 4 volts because the output here. Yeah, so I'm starting out the equation and then I'll write it like this, but once we start doing actual math, I usually just immediately, like for in my workings, right, the units just disappear. Yeah, so that's yeah. So I'm doing quite a big leap in the math here. I'll demonstrate what I actually did later. Okay, yeah. So this is our end result. How I got here, if you don't know, if your math is not strong or whatever, how I got here is first, right, I this this is a fraction, right, and then times a number. When this happens, right, this actually goes up here and multiplies. This multiplies with the numerator on top. So now we would have 6.9 R1, 1 plus R1 is 4. Then I times both sides by 1 plus R1 to get rid of the denominator. So now we will have 6.9 R1 equals to 4 plus 4 R1. Okay, that's the in-between steps. Okay, then from here, right, it's still more math. We're not done yet. Okay, wait, 6.9 minus 4, 2.9, okay. This, and then okay, so we get this 1.37931-ish. We don't need that many decimals. Okay, recall how we started with 1 kilo ohm, so our output will be kilo ohm. So okay, we found out, right, that for our output here to be 4 volts, we need the R1 needs to have a resistance of around 1.37931 kilo ohms. Alright, fantastic. Let me remove a lot of this working so that we can continue with the next part. Okay, and the next part. Using the value in part A, which is this, pick a suitable resistor for R1 from the E24 series. Okay, so now we can start applying what we just learned. We are looking for a value that is close to 1.37931 in the E24 series. So let's go and look. You can pause now to try and look for it yourself. Okay, so immediately, right, I see this and I see, oh wait, actually I see this and I see this. How I judge which two numbers to pick is, right, that 1.379 is right in the middle between these two numbers. So that's how I pick it. Okay, so now, right, we have to decide which one to pick. So we can either pick this or this, right? Yes. And this will result to be in kilo ohms. Yes. Okay, yeah. So now we have to use one of those three methods on how to pick. The first method that I thought is actually out. You can't, in this case, they're not gonna saying that I choose the smaller one and then add a potentiometer that's not an acceptable answer. So we're left with just the two ways to pick. Just pick the higher one, the higher resistance, or just pick the one that is closest to the actual value. Okay, in the paper, right, I think the correct way, right, is to just pick the value that is closest, unless the question specifies otherwise. So in this case, we're just going to pick the value that's closest, and then we will just apply the method to find the difference between the two. So to find the difference here, it will be R1. I'm not going to write out the entire thing. Minus 1.3, and the is difference is 0.07931, and then for here, right, we will take 1.5 minus R1, and then from here and then we just compute this, and then we get the difference, this number. Okay, so now we know the difference, and we can see that the difference with this number is larger than the difference of this number. So that means this number and this number, right, are closer together as compared to this number and this number. So that will be our answer. Our answer will just simply be 1.3 kilo ohms. And then we can, as our answer, we can write just 1.3 kilo ohms. And then that's pretty much it for this question. And I think that is pretty much it for this lesson as well. I thought this was simple, but it turned out to be a 30-ish minute video, unfortunately, for you guys. So sorry. Sorry it's a bit long. Okay, yeah. And yeah, that's the lesson. So just to recap what we did, I explained what the E24 series is, how to use the E24 series in a practical way, and in the paper, yeah, and also like kind of in your report, yeah. So that will be it. Thanks for watching. Yeah, all right.